Now the third question is find the Laplace transform of sine square at by t. Okay, so applying frequency integration property, we know that the Laplace transform of x of t by t is equal to integral from s to infinity x of s ds. Okay, here my x of t is equal to sine square 80. Okay, so we can't apply any Laplace transform to sine square 80, so I'm going to change this. Okay, we know that sine square 80 is equal to 1 minus cos 280 by 2, so that's what I'm going to do over here. So this will become 1 minus cos 280 the whole divided by 2. Okay, so now I can apply my Laplace transform to this equation, right? So x of s is equal to the Laplace transform of this is nothing but 1 by 2 into Laplace transform of 1 minus Laplace transform of cos 280. Okay, and the Laplace transform of 1 is 1 by s minus, and the Laplace transform of this is s by s square plus 2a, so it will become 4a square. Okay, now I need to simply substitute this over here and find the integration, that's all. So therefore the Laplace transform of sine square 80 by t is equal to integral s to infinity my x of s 1 by 2 into 1 by s minus s by s square plus 4a square. Okay, maybe I'll bring this 1 by 2 outside, so this will become 1 by 2 integral from s to infinity, okay, 1 by s minus s by s square plus 4a square into ds. Okay, so now I'm going to apply the integration inside these two brackets. Integral of 1 by s is of course log s, and integral of s by s square plus 4a square ds. Of course, last problem we have already found the formula for this, so you don't have to apply this over here, just simply apply the formula. Okay, so you will get 1 by 2 into integral of 1 by s is log s minus, and integral of, and the integral of this is 1 by 2 log, okay, log s square plus 4a square from s to infinity. Limit is from s to infinity. Okay, so this 1 by 2 can be taken as its power, so it will become root of s square plus 4a square. Okay, and this minus means I can, if I want to combine this minus means if I want to combine this, it will become division. These two factors will become a reciprocal of each other, fraction of each other. So you will get 1 by 2 into log of, so combine these two, it become s by root of s square plus 4a square. Okay, 4a square from s to infinity. Okay, from s to infinity. So now I'm going to divide the numerator denominator by s like before, same like before. So it will be 1 by 2 into log of, the reason I'm doing this is because I don't want to get infinity when I'm substituting s as infinity. Okay, so wherever possible I can make s into a denominator. If I can put s into denominator of every value that I see here, then that value becomes 0. Okay, so here If I'm dividing the numerator by s, it will become 1 by, and if I'm dividing the denominator by s, so here it will be root of. So this s dividing by s means here it will, inside the square root it will be dividing by s square. So it will be 1 plus 4a square by s square. Okay, from s to infinity. So if I am substituting these two values, I will get 1 by 2 into, let's see, this will become log 1 by root of 1 plus 0. If I put infinity over here, right, 1 by root of 1 plus 0, which is nothing but log 1. So this will become log 1 minus, and if I put s over here, I will get the same function, which is the same function over here. So it will be log of s by root of s square plus 4a square. Okay, we know that log 1 is 0, so this is nothing but minus 1 by 2 into minus log s by root of s square plus 4a square. Okay. Okay, and now if I take the reciprocal, this minus will disappear, so it will become 1 by 2 log of root of s square plus 4a square by s. This is your answer. Okay. Now let's do the next problem. Okay, the next problem is finding the Laplace transform of the equation 1 minus e raised to t by t. Okay, so I have forgot to mention this earlier. Now it's better you pause the video and try to do all these problems by yourself. Okay, since you did so much, it's a good practice for you. Okay, so let's do this problem. We know that for every problem, if you see this, I'm always mentioning my property, because that's a very important fact. It carries marks. Okay, so we know that the Laplace transform of x of t by t is equal to integral from s to infinity x of s ds. Okay, so here my x of t is equal to 1 minus e raised to t, right? 1 minus e raised to t. Therefore x of s is equal to the Laplace transform of 1 minus Laplace transform of e raised to t. Okay, Laplace transform of 1 is 1 by s minus, and Laplace transform of e raised to t is 1 by s minus 1 here, because here the value is plus 1, the factor of e is plus 1, so therefore here it will be, shift will be minus 1. Okay, so now I need to do is simply find the simply apply this integration in the above equation. So it will become Laplace of 1 minus e raised to t by t is equal to integral from s to infinity 1 by s minus 1 by s minus 1 ds. Okay, so this integration is very easy, right? Integral of 1 by s is log s, and integral of 1 by s minus 1 is log s minus 1. So I can simply write that. So this will become, this is nothing but log s minus log s minus 1 from s to infinity. The limit is from s to infinity. Okay, so if I'm going to combine these two, this will become log of s by s minus 1 from s to infinity. Okay, so now I don't want this, so if I want to substitute infinity over here, I want to make sure this s becomes a denominator everywhere. Okay, so dividing the numerator and the denominator by s, this will become log of, dividing the numerator by s becomes 1 by, dividing the denominator by s will become 1 minus 1 by s, 1 minus 1 by s. Okay, 1 minus 1 by s from s to infinity, from s to infinity. Okay, so now this is a thing, but so if I substitute infinity over here, I'll get log 1 by 1 minus 0, which is nothing but log 1 minus, and if I substitute s over here, I'll get the same value, which is the same value, so log of s by s minus 1. Okay, log of 1 is 0, so 0 minus log s by s minus 1, which is nothing but log of s minus 1 by s. Okay, so this is your answer.